All right, awesome. Well, welcome everyone. This is going to be a really amazing panel, and we have 45 minutes. I wish we had, 4.5 hours, because this is really a vast and a deep topic, and I think it's going to be really relevant for everyone in the room. So we are here to discuss improving video quality and reducing bandwidth by going beyond fixed bitrate recipes. Again, because of our time constraint, there will likely be some discussion topics or questions that you will wish that we could do a deeper dive into. At the end, I'll try and free up at least 5 minutes for some questions, and then of course, after, come on up and you're free to approach, all the panelists specifically. So I'm going to start. We're just going to try and get right in as quickly as possible. So we're not going to go with real in-depth introductions, but it is important that you know who the panelists are. And I would like David to start. Just introduce yourself, and then we'll go on down.
All right, thanks, Mark. My name is David Syed. I run product management for a company called Brightcove. I focus on the media technologies parts of our platform. So Brightcove is an online video platform, so soup to nuts, bring video in, publish it out into a player, manage it, and so on. We also have some cloud-based service technologies, cloud service technologies, such as Zencoder for doing transcoding.
Janitor, I'm a writer for Streaming Media Magazine. I review most of their encoding products, and I do a lot of consulting in this space, how to get the most efficient stream, the lowest possible, highest quality, lowest bandwidth.
Hi everybody, Daniel Sanders, Verizon Digital Media Services. I'm helping to put together a portfolio of companies that together comprise a cohesive video solution. Verizon acquired Edgecast, Uplink, more recently Volacom, and we're trying to just put together a really good, seamless way to get your video end-to-end. And prior to that, I was at Sony. I put together Crackle, the streaming video service, did that for about 7 years.
Hi everybody, my name is PBS Narayan. Everybody at Yahoo, where I work, call me PPSN. At Yahoo, my group is responsible for video engineering end-to-end. We do all the way from ingestion to delivery to the players, to analytics, ad serving, all the stuff. Our platform includes our CDN, a bunch of other things that we do for delivering the best quality to our users. We do a lot of live streaming and look forward to this discussion.
Awesome, thank you. So my name is Mark Donegan, and I work for a company by the name of Beamer. Up until 5 weeks ago, we were exclusively in the media optimization space. We acquired Vanguard Video, and now we are an encoding vendor as well as optimization. So we have solutions that address the topic today. So let's jump right in. Just to frame the discussion, so what's the problem? In other words, why should we be considering, this is sort of the question, right, that we're going to answer, why should you be looking at moving beyond a fixed bitrate ladder? And it's pretty simple. There's effectively one of two conditions that will happen with a fixed bitrate strategy. And the first is that you are either going to have more data, you're going to use more data than what the video requires, okay? Now, if you have the benefit of you're not streaming a lot of content or you're not encoding a lot of content, you can take the time to highly optimize based on the needs of that content. For example, if you're producing a Blu-ray disc, but this is streaming media, so we're not doing that. So when you're talking about distributing video at volume and encoding video volume, you run into the issue of, if I set a fixed recipe, I may be using too many bits and I may be using too little bits. So what we're going to address today are strategies, techniques, approaches, and just have a general discussion. This is, we're welcoming you into our living room, so to speak, with just an amazing group of panelists who all participate in the ecosystem in different ways. And so we have someone like Jan, who has incredibly deep encoder expertise. We have operators who are distributing. We have PPSN. Yahoo is distributing NFL sports at scale. So the perspectives you're going to hear, I hope, will be very, very relevant for wherever you are in the ecosystem. So I want to start with a question, and I'm going to throw this out. I tend to throw out a question and let the first one grab it, and then we'll go from there. So the question is, encoders are getting more efficient all the time, and especially if we look at the state of AVC H.264. It's pretty good. The open source is a pretty good encoder, and there's a lot of good commercial solutions on the market too. HEVC is improving. So what are the fundamental constraints that limit just the core ability of the encoder to be content adaptive? So why is it that as good as these encoders are, on some video content, they're going to use more bits than are needed? So that's the question.
I think that's yours.
Well, I don't think that's necessarily the case. I think with different types of content, you can do different kind of things. One of the techniques that I think a lot of people are starting to use is a technique called CAP-CRF, where the X264 codec is pretty content adaptive. But there's scenarios where that really can't work. So I think, if you're doing straight 2-pass VBR encoding, then it's not going to be content adaptive. If you're doing CRF with a cap, then you do get some measure of And what's interesting is the whole thing comes down to what's the quality metric you use to decide what the bit rate should be for that little sequence of video. And we're going to get into that later. That's where your technology comes in. But if you're using a 2-pass CBR technology or a 2-pass VBR technology, there is no awareness of content. Basically, you pick a data rate, you choose your constraints on the up and down side, and then the encoder, which is ridiculous because if you're encoding screen cams at a megabit a second, you could get the same quality 200 kilobits per second, but you're telling your encoder a megabit a second, and that's what it's going to deliver. And there are some techniques you can do to get around that, and presumably that's what we're here to discuss.
That's right. Any other thoughts, comments? You summarized it well, Jan. So I don't know if everyone saw I think it was December 14th last year, Netflix on their technical blog published a really interesting, you should go read it, basically a post that describes their approach to content adaptive. And one of the takeaways that I saw is that they found across their library that some of the titles at 1080p only required 2.5 megabits to achieve the quality standard that they had set, and yet other titles required 8 megabits. So this is the issue that Jan just addressed, that you set the encoder to target bit rate, and if your profile was 4.5 megabits 1080p, then for that 2.5 megabit, you were actually using more data than needed. So what are your perspectives? This is for the panel, and PPSN, I'll start with you because we had a conversation about this. You described very well the trade-off challenges of the compute for encode and decode, and the fact that if you have unlimited computing power on the playback side, you can do lots of cool things on the encoding, but that's not reality. So I'm curious, how has progress of encoders in your estimation progressed over the last 10 years or over the last whatever period of time, both on the encode and the decode side? Because in my mind, a lot of the fixed recipes, if you look at the TN2224 note, that was based on capabilities of devices many, many years ago, specifically Apple devices. So what have you observed at Yahoo in terms of where we're at with?
I think definitely the encoding capabilities have increased quite a bit in the last few years. In fact, I believe even NVIDIA announced one of their very high encoder-decoder cards, I believe last week. So there is definitely a lot of progress in encoding and decoding, encoding at least. But the problem is on the decoding side, where there is, at least for a company like Yahoo, where we distribute our content across multiple platforms, it becomes, and these platforms range from 4, 5 to 1-year-old or 6-month-old. The capabilities vary quite a bit. So getting really smart on the encoding side actually causes a lot of problems on the decoding side, because now your content is not is not playable well on certain devices, be it connected devices, be it, for example, I go to Amazon Fire Stick all the time just to compare across all our connected devices, and I find that even HBO content I believe if they do even 30 FPS, we see a lot of frame drops on things like Game of Thrones on Amazon Fire Stick as compared to, for example, if you directly connect it to a smart TV or something else. So adapting to the varied devices out there that are not able to decode is going to be a big challenge. And we see that quite often in our content as well as in our distribution that we see specifically with live.
Interesting.
We've certainly seen something very similar. If you look at the Apple technical notes, and Jan will be able to remind me as to exactly how many bit rates it actually specifies, putting you on the spot there. I think it's something like 6 or potentially 8. If I look at how we target devices, remember the Apple technical note is for HLS specifically on iOS devices, and that's great, but you want to use HLS to target other devices as well that are out there. And some of those behave differently. And so we actually are on the side of caution within our Video Cloud product and target a subset of some of those bit rates and resolutions as defined in the technical note, just so that we can get better device coverage that plays back reliably. Because the last thing you want is for a viewer to experience poor playback quality. That's bad, but even worse would be if you actually manage to lock up the entire device somehow by causing the decoder to crash in that device. That would be a very bad experience. So we try and be very cautious about what bit rates we're actually sending. And then, of course, the next step is to, and this is possibly where we want to go in the discussion, is great. So instead of having the one-size-fits-all set of bit rates and resolutions and recipes, what is it that you need to do to actually target individual types of devices, and how do you go about doing that?
Yeah. I think you guys, the topic you're getting into is really fragmentation, and that hitting a lot of different devices is very difficult. Actually, Streaming Media had a really good article last year from Baptiste at Hulu, and if you read that, but he was talking about all the complexity that existed at Hulu to target video to different devices. And when I saw that, I went, Eureka, this is exactly where we were with Crackle. We're doing this for iPhone, we're doing something else for older Android devices. It's very complex. And I'm not sure Content Adaptive can totally solve that.
Yeah.
But he talked about moving to MPEG-Dash to solve that.
Yeah, so I think at least from Yahoo's perspective, we have stuck with HLS. We stick with HLS across all our platforms. That way, obviously, we don't add the complexity of adding Dash or some other type of encoding and actually figuring out which encoding works best. But the smarts that we have done is we have tried to figure out what the user agent is, what the device is, what the firmware version is, what the capabilities of those devices, and then selectively filter out what kind of profiles we send to the device and which CDN we send the device to.
Yeah.
Because certain CDNs are also not very good at certain capabilities.
But I found that trying to manage that kind of portfolio, video, you have to remember that the quality of the video is not the only thing.
Yeah.
It's one of the things. Sometimes, hate to say it, you do have to take a good enough approach. If you're going to have an incredibly complex workflow and you're going to deliver the optimal video to each device, if you're Netflix, maybe you can do that. But if you're a smaller operator, sometimes you have to cut a corner to get your workflow working and reuse a profile that you made for one device on another device. So, if innovations that companies like yours, Mark, are working on can solve those issues and have a unified workflow, I think that's part of what we're also doing at DMS. We're trying to simplify the workflow. So I'm all for that if we can get to the point where common encryption, common encodings get us to where an operator can stand up a service targeting multiple devices much more easily, because I see what you're talking about from Yahoo, what I've seen at Hulu. There must be hundreds of software architects at different companies doing exactly the same thing, pretty much. And what they're doing is not that elegant.
So another interesting problem that you start wondering about is that we have built years, maybe not a decade, but at least years of ABR and Player Smarts on figuring out reactively most of the time on what is happening in the network and how do we react to that in the network. And now we start looking at content and proactively start understanding what kind of bit rates to send. The interesting problem then becomes is how do these two interact with each other, and do they work well together, or actually they work worse and make things bad because certain players may see lower bit rates when the content is not changing much and may think that everything is fine and may not switch bit rates, and soon later you see content that's like shifting a lot and games being telecast, and suddenly from talking heads you move to action, and then suddenly the player just blows up, right?
You mean you have something that works well in isolation, but when you put it together with a certain type of network?
Yeah, exactly. Certain type of network, certain type of player smarts. Do these actually work well together, or do your rebuffering rates actually increase? Right. Your final goal is to not show the spinner. That's the goal of both ABR and CBR, or kind of coming to a point where finally the goal is to not show the spinner to the user.
That's right. That's right, and certainly that's reality, where even if we're focused on delivering premium video quality, at the end of the day, the spinning wheel, the rebuffering event is fatal. If you're ad sponsored, the viewer's going to click away. If they paid for the stream, they're going to say, what did I pay for? So no doubt about it. So I'm curious then, what are some techniques or approaches? And David, I guess I'll start with you, because Bright Cove operates a platform. You have the unique challenge that you have users that have expectations, I'm assuming, that are across the spectrum, from extremely high quality, absolute, pinnacle of video quality, all the way to, because their business model, maybe not so. So how do you balance this, what the conversation we just had about the fact that we have to avoid the rebuffering event, that's mission number one, but then you have users that say, but at the same time, give me quality. So what are how do you approach that? What tools do you use?
Well, I hate to say it depends, but it depends.
Yeah.
Depends on the
give us a peek under the hood.
It depends on the user. It depends on their expectations, and there's definitely for some customers, typically doing things like behind the firewall type video where it's screen captures, talking heads, and so on. The quality of the video to start off with is generally not great. I mean, yes, it's HD, but it's poorly lit, and actually oftentimes that's really hard to compress well. It starts to show lots of interesting artifacts. And so, we start off with essentially, a fixed set of recipes that I would say is loosely derived, and we deliver HLS everywhere, by the way. So it's loosely derived from the Apple technical note with some changes that we found have worked well for us over time. And that tends to work well for the majority of types of customers that we're viewers that see the content. So they might be viewing it from anything, on anything from an iPhone to an Android device to a browser. But then we get the more advanced customer, the ones for whom the quality of the video is absolutely key. And they typically will come to us and say, well, these are the preset, these are the profiles, these are the encoding settings that we actually want, and how close can you get to those, and so on. So in some of those cases, we'll actually turn it over to themselves. Where it's left up to us to decide, we'll go off and we'll spend some time evaluating, and we'll take a look. We'll use various tools quality checking tools to go off and compare different codec settings. And it depends on the product as well. So, we have a cloud-based transcoding service called Zencoder, where that's really left up to the customer to go off and decide what profiles and presets and bit rates they actually want to go off and choose. Oftentimes, in fact, just last week, I had a conversation with a customer saying, but tell us what settings to use. We want to deliver the video. You tell us what settings will make it look great. And you then get into this conversation around, well, what kind of video is it? What devices is it going to? What are the kinds of things that you're able to go off and optimize? And it was really more of a, in fact, I turned them over to you and said you should go and talk to a gentleman by the name of Jan to get some advice and figure out how to measure the quality of what your viewers actually expect. And one of the tools that Vanguard has, actually, the player tool, whose name I can't actually remember off the top of my head,
VCT.
that's the one, VCT, has a really great way of comparing two different video files or multiple different video files that have been encoded differently, and you can then visually compare the two side by side. And it's really, to see that in front of your eyes as opposed to just a set of data metrics that mean different things to different people is really very telling. So we use a variety of different techniques.
So Jan, how does someone, I know you've written some blog pieces on, some blog posts on your blog about this. How does someone who's listening to what David just said say, okay, but how do I take this to an automated, a more automated, so it's not such a manual process, using a quality measure or some other techniques? What can you tell us about some approaches that might be possible?
There's a range of approaches. So if depends on the type of content that you're working with. I worked with a training vendor earlier this year, late last year, and they had very specific types of content. They had screen cam videos, they had talking head videos, and we were able to come up with category-specific encoding that said, if it's screen cam, no real-world video, do this. If it's talking head video, do this. That approach works well within very defined limits. Tried to do the same thing with a client that had animated movies, adult movies, and real-world movies, and that just didn't work at all. There was just too much diversity in the content. So I think you try and, if you've got content that lends itself to category-specific encoding, you try that first. Another approach we talked about at the start was CRF encoding. And with CRF encoding, it's an interesting technology that basically you choose the quality level and you can cap it, and then it will deliver the lowest possible data rate that the content will allow, capped at whatever you set. So that's something that we try. We're starting to see different compression companies come out with different alternatives. So there's a company called Capella that's got an encoder called Cambria that what it'll do, it'll go out and do a quick snapshot of the file. And it's not quick, it'll encode it with CRF, figure out the level it needs to achieve overall quality, and then it'll customize the encoding settings for that piece of content. So it's per content, it almost accomplishes close to what Netflix is doing, but it's not quite. I mean, but it gives you a snapshot of how difficult this content is to compress, and it is totally automated. And then I think that the best thing you would want is a technology like what you guys have, which is not only content aware, but it's also even section aware. You know, if you apply one setting, one data rate to a video file, you're going to have sections that are over encoded and some that are under encoded. Yeah. And what your technology does is basically it does that on a frame by frame basis or a section by section basis. So it'll make everything as efficient as it possibly can be throughout the course of the video file. So my approach is typically, can you do category specific encoding? If so, then try that first. Every encoding tool is going to have this per title encoding stuff I talked about. It's not rocket science, but it's not perfect. I mean, that's kind of the second level. And then I think the third level is, a technology like yours, when you somehow integrate it into a codec like the Vanguard codec, I think that will be, the ideal solution depending on cost, workflow, time, all that stuff. So that's kind of the range of solutions as I see it.
That's excellent. Yeah. So,
but let me just make one point. I mean, what I heard from these guys. I mean, that's the compressionist technologist. All that stuff's irrelevant if it doesn't play on. So I think you really need to, that there's whatever you do on the encoding side has to be supplemented with a lot of trial and error on the playback side, because what can look great in a lab can be totally irrelevant out with different devices.
Well, and I think Daniel's earlier point, which is really key, is how important is it to you, really? How much time are you willing to spend? Because you can spend an infinite amount of time on this stuff. Yeah. And it will keep getting better and better and better and better. And at some point, you need to say, great, this is good enough. And maybe and I think this was the point one of you was making, for certain types, good enough for certain types of content is going to vary. Presumably because you are all here, you all care about video quality and video delivery costs and things like that. But I would say there's probably 80% of people out there that don't. You know, as long as when they press the button it plays, and it's not dropping frames crazily, and it's not pixelated beyond recognition, that's okay. So you've already self-selected yourselves into a group that actually cares about this stuff.
Yeah, but the counterbalance to that is everybody cares about, you know, the bandwidth, particularly mobile bandwidth. So I think it's incumbent upon, if you're producing video for mobile, you know, it's incumbent on you to, you know, to deliver the best possible quality at the lowest possible bandwidth. And even with, you know, with some of the broadband vendors starting to put caps, I mean, I cringe every time my kids are watching Netflix. It's like, not that Netflix is bad at this, but, you know, it's not $8 a month, it's $8 a month plus the $50 extra that Comcast has thrown at me.
Well, now they have the mobile button.
Yeah, so it's I think everybody needs to care about, if not quality, then certainly bandwidth, and I think everybody cares about quality as well.
Yeah, I mean, I've been talking, you know, as we approach this date, I've been talking to a lot of our CDN folks, trying to get a really clearer picture within the Edgecast CDN. How do people feel about bits versus transactions? Asking them, do you really care if a bunch of TS segments are 20% smaller, if we're still doing the same amount of transactions? And we have 75 POPs around the world, huge amount of traffic. And the answer was yes, they do care. Caching servers, disk utilization, network utilization, all these things are always approaching the red zone where you have to start thinking about capacity planning, building out the next POP, ordering hardware. It gets into that uglier side than software where you don't just sit down and write code. You have to start racking servers and...
But that's because you're already delivering at scale. You know, I work with a lot of startups, you know, and they have an interesting business idea, and so just getting the thing working is their first step. Yeah. Then when the builds start coming in, absolutely, it all becomes very important.
Yeah, then they call you looking for, is there a way to reduce?
How do we make it?
I mean, on the point of video quality and how people think about it, when I was at the hotel yesterday, I was actually watching Sci-Fi Channel, and the video looked good, but I was actually thinking that the goal of good quality video is that you don't think about video. You know, I'm looking at it thinking about how the video looks, but a real viewer should never even think about it. So, you know, I'd put that personally as being one of the things to strive for, that somebody who's watching your stuff never thinks about that kind of thing, like, oh, you know, Jerry Seinfeld's face looks pixelated, or,
That's right.
I think it's bringing, like Daniel was saying, it's bringing what I call as TV-like quality, where you put two screens and you watch TV broadcast on one screen and OTT on one screen, and you should not be able to make out the difference. It's kind of the Turing test for OTT streaming, and I think we are close, but we are still far away. It's kind of the quality of TV increases. We get 4K, and now we have to deliver at 4K because now you want to be able to distinguish between whatever 720p and 4K.
But so over IP, it doesn't quite work yet.
Exactly. So it's a game that we continuously had to be playing, and hopefully at some point TV will be playing catch up to OTT, and which is not far away.
That's right. That's good. That's what we're all working for. So I am aware that our time is almost up here. We have about 15 more minutes. So I do want to leave some room for questions. I'm hoping there'll be some good questions that we can dig into. So to summarize, Jan, the approaches that our audience could take in if they say, this is great, I understand the value, I do want to look at moving beyond just my fixed rate ladders, my fixed bit rate ladders. So there's the manual approach, and that's, and David, it sounds like even in some cases, even Bright Cove ends up working just manually with an important customer, and you look at some encoder settings and you advise them, right? And then the manual approach allows you to categorize, so I know it's synthetic content. I have a certain idea of what encoder settings work well, but it's manual. It's sort of, it's very rudimentary. And then I guess you can move into some encoding tools like, you mentioned even CRF, which can provide, can go a certain way, but will fall short for some video. Again, you're sort of in the same problem. Some video, it'll work great, some it will not. And this is what we've seen with our customers too. When we're given CRF files, sometimes they're really amazingly good, and then the next file is awful. It's a fixed recipe at the end of the day. And then there's, you mentioned that there is the quality measure-based approach, which is what, like what we do, and there are other quality measures on the market. So really it's a matter of how closely correlated that quality measure is to human vision and being able to detect artifacts. And then that's where you can get into more an automated optimization, if we want to use that word. So I would like to get the panel's thoughts, and whoever wants to grab this first, but I think everybody can and should contribute to this next question on, practically speaking, implementation. So we've kind of talked around, we've thrown out some different approaches, ideas, some strategies, but how does a company who doesn't have an army of engineers like Netflix, which is pretty much every one of us in the room, unless there's someone here from Netflix, what can a company do? And Daniel, I'll start with you, because you were at Crackle, and you had a very capable engineering team, but
15 people.
Yeah, exactly.
But everyone's booked on something.
Yeah, that's right. So you had
doing that.
You had a Navy SEAL team, but you didn't have an Army. So
Yeah.
so what did you do? And and then I'd like the others to jump in as well and just.
What did we do specifically to improve quality
how did you
each time?
exactly, and how do you approach? What could someone out here who has 15 engineers do to begin to adopt something?
Yeah. Okay. So you remember with Beamer when we did images with you guys. We didn't do video, which I could talk about in a little while, and I think you have solutions for that now. Yeah. But for images, you just make things work. Everything you've done, you've painted yourself into some kind of corner. Every choice you've made is 3 choices you haven't made. You've built some stuff. It's sitting there, and what I'm getting to really is you just need to find things that can be drop-in replacements, that can be compatible with things you've already done. The way we did the image optimization at Crackle showed great results, and the integration was a S3 bucket type of integration. So it was pretty easy and seamless and involved switching CNAMEs to get things done. At the time, we didn't do the video piece. I think it was because it wasn't compatible with our DRM packaging, pre-Vanguard, prior to your Vanguard thing. But like you said, SEAL team, it's always strategic, last minutes. Can we get it work? Can we get it working in the 3 weeks that we have to launch this app? It always seemed like, with Crackle, same as that Hulu article, if you want to read that. Baptiste talks about the same thing. For the last 5 years, when I started on Crackle, it was a UGV website. And then suddenly all these devices started flying at us. And we have 4 months to launch the iPhone app. We have 4 months to launch Roku, Apple TV, new version of the Xbox with changes on and on and on. So, like David said, it depends. But things that currently, when I'm looking at solutions like yours, we've built a lot of our architecture for encoding around FFmpeg just because there was strong allegiance to open source within Uplink, the server-side ad insertion company that does most of our transcoding. So right now I'm looking for things that are compatible with what we have already.
Sure. So PPSN, yeah.
So I think a lot of what Daniel said resonates. I think one of the key things, probably, I don't know if you'll have time to talk about it, is the difference between live and VOD, where I think with Yahoo, we have been working on a lot of live content. Yeah. And for us, making multiple passes, figuring out whether we can do much more content-aware optimizations becomes very difficult because we want to already add to the broadcast delay that you have already with HLS. You already have 30-second delays, and you don't want to add to that. We are actually trying to reduce that, right? So encoding becomes a challenge there. Not only that, I think encoding, especially if you're doing, I'll give you a few examples, doing things like sports where, each sport has its own type of challenges if you want to make it content aware. For example, with golf, we do PGA Tour golf a lot, and many times I go and start watching golf, and I think it's stuck and the frame is stuck because they're so still during while taking a putt, and it's like 2-3 seconds where it's so still, and I think, hey, it's like frozen. Actually, it's not, and you can do a lot of great optimizations there. But if you take the shot and you see a small golf ball flying through the air, through the sky at very fast pace, you potentially cannot do that through trees and things like that.
If they would just get rid of the ball, it would be a lot easier.
Yeah, so that's golf, right? And then you move to talking heads, which comes during the golf game. So it's like different type of content coming in that game that it becomes very difficult where you can't make it frame aware, you can't make it content aware, but you can make it segment aware. Yeah. But you don't know the segment in advance, so you cannot. You kind of have to have these smarts in the encoding algorithms where you start predicting what's coming, right? So I think those kind of technologies and those kind of thoughts have not gone through enough that we can tell the elementals or tell the encoders that, hey, once talking heads start, usually it lasts for like 15 seconds. So shift your encoding type. So those kind of smarts are not there yet, right?
That's right.
So we go with fixed profiles as well, but we do filter the profiles out based on devices, based on a bunch of things. So we know if a device is coming and is not capable of certain things, we don't serve certain bit rates or certain profiles, certain package to them.
I'm really glad that you brought up the difference of VOD and live. With VOD, when you don't care if it even takes hours to encode that file. You can do all kinds of things. With live, you can't. For Beamer, our live solution, we actually operate 3 encoders in parallel and then use our quality measure to pick what we believe is the best. Requires a lot of CPU, but it's that way to solve the fact that you don't have a look ahead. You don't have the benefit of knowing what's coming. So it's an interesting problem. Any other quick thoughts? And then I do want to go straight to questions.
Actually, another interesting thought which we couldn't talk about too much is decoding on mobile phones. Battery consumption becomes a very critical aspect there, especially, and depending on the content type, how much decoding you do for live content and for content that people consume for a long time. If you really make it hard to decode, the battery consumption dies very fast, and that also adds to the mix of all the problems that we have, not just about whether the device is capable or not. Yeah. So those are the kind of considerations that we have to start thinking about.
So I warned you that this could be like a 4-hour conversation. So now you see why. We've been going 40 minutes and we're just getting started. So I want to open up for questions. Yes.
What would you guys think the advantage and the disadvantage would be when controlling our bit rate based on having a third-party encoder or building our own encoder through like X264?
Okay, so I'm going to rephrase the question for the video. So what are the advantages to controlling bitrate based on utilizing a third-party encoder or leveraging something like open source, X264? Trade-offs, in other words. Yeah. I have an answer because that's why we bought a company. So I could give you personal experience of the challenges, but I'm going to let the panelists.
I think the real answer is that a lot of the third-party encoders are getting much more sophisticated than what's out there in the open source world. But I think Jan has a lot of expertise on that. That's my take as somebody. Personally, I'm not a deep video encoding person, but I've spent a lot of time putting together services both on the content side and now on the provider side. And there's a lot of companies out there that are doing sophisticated things along the lines of Beamer. I think the challenge now is working out which ones have the value and how you can integrate it into your workflows and what kind of effect it's really going to have on your service. If you're running a service and that's an incremental cost that you're adding to your operating expenses, how is this going to affect my retention for my service and so on and so forth.
Any other questions? No. Yes.
So now that we're starting to see initial deployments of devices that support next-gen codecs like GPC and VP9, do you still feel there's as much value in spending the time and cost and everything to actually use any of these optimizations in
Okay, so I'll restate the question again for the video. So the question is, with next generation technologies like HEVC, and now that more devices are proliferating, is it still worthwhile investing in optimization, and optimization specifically on AVC, I think is what you're asking, right? Okay.
I certainly think there can be. I mean, I think we've looked at a number of different video optimization technologies, and in many cases, the same basic principles can apply to the next generation codecs as well. So that's one point. Just because most of these technologies are being deployed in the AVC world today doesn't mean that similar techniques can't be deployed in an HEVC world, or potentially even a VP9 world. The second point is, obviously, the HEVC, while it is available on different platforms, isn't as widely deployed as H.264. So you might be able to get to a certain number of your customer base by going with HEVC, but then you've got to go off and do that particular set of encodes, another set of renditions to manage, not to mention the royalty issues surrounding HEVC. And then the third point is just if you look at how codec technology improves over time, the HEVC codecs still aren't as optimized as, say, H.264 is right now. So you do get savings by using HEVC, or in terms of bandwidth, but they will probably get better in time. So those would be my 3 points. Excuse me.
Anyone else? I think we have time for one more. Yes.
PBS had mentioned that a client side may not know the quality that it's getting, right? And it might be at a certain bandwidth and just be oblivion to what's going on. Can we make the client side aware of the quality through some mechanisms, and would that have to be standardized? And what, as a panel, how would you go down that path so that everybody's playing by the same set of rules?
Ideally, there should be.
So I should restate the
Okay.
question, sorry. I was ready to hear your answer too. So the question is, how can we make the client side aware of capabilities, and it sounds like where you're going is, how could we get the server side to be talking to the client and improving quality at the player? So
I think, like I mentioned, ideally these two sides of the coin should talk to each other, otherwise it's not going to work very well, especially if the bit rates, the encoding becomes more efficient, but the bit rates are not showing that. I don't see a standard body still thinking about it. We have this interesting alliance called Streaming Video Alliance, which I think some of you guys here are also part of. This is some of the things that we should discuss in those kind of industry forums and kind of make it into a standard. That's my thought. I'll wait for some other folks to talk about as well.
I mean, there's two different issues. And I always get these confused, but there's quality of experience and quality of some other quality.
Yeah.
Yeah. So one is how well is the video encoded, and then the second part is how well is it delivered. And I think on the delivery, and that's a whole different. Companies, Conviva is big in that, NeoQuest is big in that, and I think there's some interesting movements towards a standard in that area but I think we're a long way away from it. I mean, and really you need to address it as a totally separate issue. One is encoding quality, the other is deliverability and quality of delivery. And they are related, but they are separate issues.
Can I make a comment on that question? So, I don't know, Netflix made something similar announcement or in one of the events at Facebook, where they actually use a new quality metric, which they actually give it back to the player to make decisions based on. So it's more making it more quantum aware using those quality metrics.
that's right.
They were planning to put a blog post out there, I don't know where it's out there.
Excellent. Okay, yeah, thank you. All right, well, please join me in thanking our panel. Thank you for attending.